Hello everyone, welcome to my YouTube channel Flow and View. So previously I saw you how to create unidirectional composite in ANSYS and how to estimate the elastic property of that unidirectional composite. So in today's video we are created a woven composite and we are determined the elastic properties of this woven composite. So before the simulation we talk about some basics of woven composite. So you see my slide here. So, okay. Firstly, open composite is a special type of fiber reinforced composite where the yarns are interlocking with each other in a specific pattern. So, there are three types of woven composite. So, one is plain woven and twill woven and satin weave. So that is where you see my cursor. That is called yarn, and this yarn is also made by fiber and matrix, and that is unidirectional. And these yarns are interlocking with each other. The horizontal yarn is called wrapped, and the vertical yarn is called weaved. So this is wrapped and weaved are interlocking to create a woven composite, and the distance between two adjacent center to center distance between two adjacent yarns is called yarn spacing, and the thickness of overall fabric is called fabric thickness. So this is our basic of woven composite. So let's go into the ANSYS to solve to create a woven composite. ANSYS workbench. At this moment, woven composite are more dominant in any type of industry, such as automotive industry, aircraft industry, because of its fiber direction. Normally, in unidirectional composite, the fibers act as a one direction, but in woven composite, fibers are act as a all direction because of due to this all directional load and stress are distributing more accurately throughout the geometry. That's why woven composite is so much promising at this time. So for creating a woven composite, you need to system of material designer. You see here. So drag this material designer. Okay. So firstly, you choose your fiber and matrix, and at first we create a yarn, then we created a woven composite. So our first task is creating a yarn. So go to the engineering data for choosing our fiber and matrix. So there are inbuilt engineering data sources from composite material. So go to the composite materials and select your fiber. So I choose here fiber for carbon fiber, 397 GPa, and also I choose our resin is epoxy resin. You can choose any other fibers, or you can customize your fiber like jute fiber, flex fiber that are not built here. So you can customize your fiber. Okay, so our fibers and our resins are including in our engineering data. So let's go into the material designer section. So in composite material, our main aim is to increase their strength and reduces the load, reduces the weight, and because of composite material are used in aircraft or in wind turbine. So why we use high weighted material in wind turbine? That's why composite material are promising of this sector. Okay, so our material designer interface is shown here. So firstly, I previously mentioned that firstly you created a yarn for creating a woven composite. So let's go into to let's go to create a yarn. So go to the mat. So firstly we selected the RV. So in my previous video I explained what is RV and how many types are RV we show. So we choose unidirectional RV and matrix. Assign your matrix is resin epoxy and assign your fiber is carbon fiber. Then go to the click. Okay. Then go to the geometry. So our RV is we need hexagonal RV and fiber volume fraction is 0.5. So okay, that's normal. And fiber diameter also shown here. Okay. So you can customize your fiber volume fraction and your fiber diameter. And go to the meshing section. We use block mesh and conformal meshing. So okay, this is our meshing geometry. And go to the settings. So you can find here you can see the types of anisotropic. So compute linear elasticity. So from this section you can find out the elastic properties of this composite material. Also you can find the evaluate the value of thermal conductivity or evaluate the value of thermal expansion from this. So in this simulation we are not need to thermal conductivity or thermal expansion. We just evaluate the linear elasticity of this material. So we also is much okay. So click the right button. Okay, our analysis setting is almost done. Then go to the analysis. So our material is constant material. So why we use constant material? I reason why the reason we use constant material. I answered in my previous video. You can check this. So constant material. So material is carbon fiber yarn. So carbon fiber yarn. Okay. Then go to the. So now ANSYS solve this problem and find out the elastic properties of this unidirectional yarn. In woven composite, there are four important parameters that influencing our strength and stiffness and elastic properties. This is four properties are called fiber volume fraction, and second is yarn fiber volume fraction, and third is fabric thickness and yarn spacing. This is four parameter are most promising to influence the elastic properties of a woven composite. So you need to evaluate how the effect of these four parameters. Okay, this is our yarn is almost created. So let's check the yarn's property, elastic property. So this is the elastic property E1, E2, E3, G1, 2, G2, 3, G3, 1, new 1. That means Poisson's ratio. G means shear modulus and E means Young's modulus in longitudinal direction and transverse direction. G12 means in plane shear modulus, and G23 and 31 is out plane shear modulus. And new 12 is in plane Poisson's ratio, and 23113 is out plane Poisson ratio. So our yarn is almost done. So using this yarn, I created a woven composite. So before go to create woven composite, firstly you need to update your material designer. Okay, our material designer is updated. So you need to another material designer section, and you input the material designer yarn value into engineering data section and update the engineering data. So what we have done here, we done in material designer one section, we created a yarn, and this yarn we are transferred into our secondary material designer section where we created our woven composite. And let's go into the material designer 2 section. Okay, so here we choose our woven composite RV. So click the woven composite and choose the matrix is. So our in this section our yarn is carbon fiber yarn, and our matrix is resin matrix. So we need to include in engineering data section and go to the engineering data and add from the composite material resin epoxy. Then go to the project. Okay, so our matrix is resin epoxy and our yarn is carbon fiber yarn. Then go to the geometry. So here you can see the woven type. So I already mentioned there are three types of woven are shown. In one is plain, twill, and satin weave. So in ANSYS, in here you see only plain and twill weaves because mostly plain and twill weave are used in different industries. So you can change your plain to twill or what you can need, and you can change fiber volume fraction. That is important for creating a woven composite. So our fiber volume fraction is you choose a random value, so 0.45. Okay, and yarn fiber volume fraction. So You know that our in our material designer section 1, our fiber volume fraction of unidirectional composite is zero point 0.5. So yarn fiber volume fraction is also zero point 0.5, and the shear angle is 0. Okay, fabric thickness, yarn spacing is 1, and fabric thickness is zero point 0.2. Okay, no need to change anything. So align with x direction. And our algorithm is we need here high fiber volume fraction flattened lenticular algorithm. This algorithm is provided very accurate result. So when you creating a open composite, you need to select your algorithm for flattened lenticular and click the right button. Zero point 0.85. So 0.8. Okay, so I need to change my yarn specification. So fiber fraction of yarn is zero point 0.8. Okay. Let's update the full step. In general, natural fiber composite or any synthetic composite, the yarn fiber volume fraction range is 0.75 to 0.85. So in our problem, I choose yarn fiber volume fraction is zero point 0.5. That's why ANSYS don't solve it. So you need to choose your yarn fiber volume fraction from 0.75 to 0.85. Okay, our yarn are created. So let's check the elastic properties of yarn. So here you can see the elastic properties of yarn in uh, shear modulus or Young's modulus and Poisson ratio. Also, you can see from the density, and you can evaluate the thermal conductivity or thermal expansion values also. So, okay, then go to the update, the yarn section. Okay, also update the engineering data for material designer part 2, and go to the engineering designer, material designer. Okay, so firstly go into the material, and our material is matrix is resin epoxy and yarn is carbon fiber yarn. So go to the right click button, and then go to the geometry. I already mentioned that there are four type of parameter that are influence the strength or the others mechanical properties in a composite material. So first is weaving type. So normally twill weave shows better perform, so you can choose plain or twill weave. So for my simulation I choose plain weave, and the fiber volume fraction is 0.6. So in natural fiber, normally fiber volume fraction is range is 0.1 to 0.6, but in synthetic fiber that is 0.7. So I choose here 0.6, and also yarn fiber volume fraction 0.8. The others is almost done. Okay, let's click the right button. I guess this time ANSYS can solve this problem. Okay, so ANSYS could solve. So you can see this is our woven composite, but this is our weave, and this section is our yarn, that is horizontal yarn, that is called wrapped, and this is our vertical yarn, that is called weaved. So okay, our yarn is almost created. So let's go into the meshing section, and we use here in not periodic mesh, use block mesh and conformal mesh. You can't customize your meshing in design modeler, material designer. So there are inbuilt some meshing section, block mesh, conformal mesh, or periodic mesh. So if block mesh and conformal mesh are solved, so you can choose it. Otherwise, you can choose periodic meshing. I guess block mesh and conformal mesh are solved my geometry. Normally, open composite simulation are taking two time, so you need better PC for this type of simulation. So you can see ANSYS are generated bad element. So block mesh and conformal mesh is very bad for this type of RV. So you can choose periodic meshing that give better results. So okay, so go to the settings and as usual you can choose only compute linear elasticity, or you can also compute the thermal conductivity here. So okay, then we solve our problem. So in analysis we choose constant material, and our material name is carbon fiber woven composite. And then you go to the complete the solving this. After some basic analysis failed, okay, go to the settings and use periodic meshing. This is off. And okay, so I choose here for block mesh and conformal mesh. So you need to change the setting section to click. Acha, okay. Block mesh and conformal mesh are not solved, so yeah, I choose here for periodic mesh, and also the type of anisotropy and generalize is periodic boundary conditions, and update the full setup. Now it can take 5 to 10 minutes to solve this RV to determine the elastic properties. Meshing is complete. So now ANSYS use periodic boundary condition and solve the problem. Okay, the solving is start. Okay, I will show the elastic result of our open RV or elastic properties in my next video.